This video is sponsored by MOVA Globes, unique gifts for all space lovers. And not only. At the end of this video, you'll find out more about how to embellish your work table with a spinning globe that doesn't require recharging. On September 28, 1969, a fireball streaked across the skies over Australia. Shortly after that, a strange 100-kilogram meteorite was discovered near the town of Murchison. Witnesses claimed it smelled like tar. But how is that possible? Lab tests showed that the Murchison meteorite is surprisingly rich in organic matter and contains several dozen amino acids, and all of those are the building blocks for terrestrial organisms. But when the researchers looked at the meteorite under a microscope, they were shocked. The rock from outer space was modeled with microscopic structures very reminiscent of the remains of bacteria. But the weirdest part is that radiocarbon analysis showed that this living meteorite is 5 to 7 billion years old. That is, it's older than the solar system itself. All this led American planetary scientist Lindy Elkins Tanton to a revolutionary theory. What if life in the solar system first formed not on Earth, but much earlier, on planetary embryos in the protoplanetary disk? In that event, the entire near space may be teeming with various bizarre organisms. If that's the case, where could we overlook extraterrestrial life in our solar system? So far, scientists consider Mars a prime candidate for finding extraterrestrial life. Back in the 90s, this Martian meteorite surprised the scientific world with unusual inclusions that looked like fossilized bacteria. But all this is just circumstantial evidence. Scientists hope to catch life literally red-handed on Mars itself. And the Perseverance rover has recently pitched NASA a potential sensation. In the summer of 2022, it collected several new rock samples from the Jezero crater. Scientists suggest that about 2 billion years ago, before Mars lost most of its atmosphere and dried out, a large lake with a river flowing from it stretched across this area. On Earth, such ecosystems are teeming with life. In previous years, Perseverance already found some organic compounds in samples from the Jezero crater, but this time it studied mud samples from the bottom of an evaporating saltwater lake. The results stunned scientists. They saw a record number of sulfate molecules, usually found in mollusk shells. On Earth, the first such organisms evolved only a few hundred million years ago. But what if, long before that, their ancient fellow beings inhabited Martian water bodies? Moreover, considering the red planet's weak gravity, local species could reach gigantic sizes. Alas, the rover's field instruments are not capable of confirming or refuting such a hypothesis. The samples have to be studied in a full-fledged laboratory. NASA plans to return them to Earth sometime after 2027. But while we're waiting for news about ancient fossils, something is breathing on Mars right now. Another NASA Mars rover, Curiosity, has been measuring the composition of the Martian atmosphere for many years. It is primarily composed of carbon dioxide and minor nitrogen and argon impurities. The Martian atmosphere has only 0.1% of oxygen, since Mars is believed to have no plants capable of producing it in sufficient quantities. However, measurements obtained by Curiosity over a period of nearly 5 years in Gale Crater revealed 2 unexplained anomalies at once. During the Martian spring and summer, the planet's oxygen levels spiked and were much higher than geological processes could possibly provide. At the same time, an abnormal amount of methane appeared over the crater. It was dozens of times more than the calculations predicted. This organic gas is produced by many terrestrial bacteria, particularly those living in the intestines of large animals like cows. But no one at NASA has any idea what's causing the various methane levels on lifeless Mars. But what if we didn't dig deep enough in our search? The Mars Express orbiter conducted multiple radar surveys of the Martian polar regions, revealing only ice deposits. But when the engineers readjusted their frequencies, in the depths, they discovered an anomalous layer that absorbs radio waves. And here's the most realistic explanation: hidden underground lakes. Such exotic water bodies are common on Earth. There are several hundred of them under Antarctica alone, and in the largest of them, Lake Vostok, scientists found abundant organic traces of bacteria that don't need oxygen. Many DNA samples didn't match any species known to science at all. But on Mars, life in subglacial lakes could be even stranger. Such mysterious ediacaran organisms lived at the bottom of Earth's water bodies about 600 million years ago. Paleontologists are still unsure whether these are plants, animals, or something in between. The answer can probably be obtained by exploring the lost world of underground Martian lakes, which may be inhabited by similar creatures right now. After all, the catastrophic drying caught them in the early stages of evolution, and since then, these organisms have been sort of preserved in their small ecosystems. We may have already picked up the echoes of their breath in the form of abnormal gas bursts on the surface, but to make a real discovery, NASA's vehicles have to learn how to drill sufficiently deep wells. But in recent years, extraterrestrial life seekers have also been attracted to other planets previously considered completely dead. The latest research shows that living beings might well have survived even on the hottest planet in the solar system. Some 60 years ago, many considered Venus a tropical paradise, somewhat of a jungle-covered prehistoric Earth. In fact, Venus is not only almost identical in size to Earth, but it also lies within the habitable zone. That is, Venus is theoretically capable of supporting liquid water. However, in the second half of the 20th century, space probe expeditions discovered that the dense Venusian clouds actually cover a scorched volcanic landscape with truly hellish conditions. The temperature here reaches 475 degrees, and the pressure is 90 times stronger than on Earth's surface. All this is in an atmosphere composed almost entirely of carbon dioxide, with impurities of sulfuric acid. However, further research showed that Venus was not always such a hellhole. Initially, it was not much different from Earth and could indeed have liquid water on its surface and consequently all conditions for the development of life. However, at some point the planet experienced a runaway greenhouse effect, which caused its oceans to evaporate and disappear into space. Venus boiled and was unable to cool down. According to the first conventional theory, the catastrophe was caused by abundant asteroid impacts 4 billion years ago. That is, almost immediately after the formation of Venus. However, in a new study conducted in 2019, Dr. Michael Way and his colleagues from NASA Goddard Institute offered an intriguing new explanation. Their simulations revealed that Venus may have had a stable and relatively comfortable climate for 3 billion years. That's more than enough time for life to evolve. That means the greenhouse disaster hit the planet only 700 million years ago. Way suggests that it was caused not by the asteroid bombardment, but by a cascade of global volcanic eruptions that released far more gases into the atmosphere than it could naturally process. If Venus were further away from the Sun, for example, in Earth's orbit, it might have coped with catastrophic overheating and would still be teeming with life. But that doesn't mean there's absolutely no trace of the ancient Venusians. In 2020, a team of astronomers led by Professor Sarah Seeger studied the spectral fingerprints in Venus's atmosphere and detected an excess of phosphine in its clouds. This toxic gas breaks down quickly, and hence something or someone constantly replenishes the reserves. On Earth, phosphine is produced by sulfur bacteria living in extreme conditions without oxygen. In the clouds of Venus, they would feel at home. Besides, Japan's orbital probe has discovered that something in Venus's atmosphere actively absorbs the sun's ultraviolet rays, which is also a favorite activity of bacteria. Based on this, astrobiologists have created an incredible picture of life on Venus. Local microorganisms live at high altitudes where they never feel too warm and reproduce right in sulfuric acid droplets. However, skeptics habitually attribute all these anomalies to natural processes. In addition, it's not entirely clear how much phosphine actually resides in the atmosphere of Venus. This data should be clarified by NASA's upcoming missions, such as the Da Vinci Plus probe, which will launch a heat-resistant capsule with various sensors into the Venusian atmosphere in the late 2020s. And it's entirely possible that they'll find not only extreme bacteria, Volcanic overheating on Venus has lasted millions of years. What if some species have adapted even to the infernal conditions? New models have shown that the enormous pressure and temperature turned carbon dioxide near Venus's surface into a supercritical fluid. It's an extreme substance that exhibits both gaseous and liquid properties. This means Venus still has an ocean. It's just not made of water. It's easy to imagine that extraterrestrial animals such as grass snakes and jellyfish have adapted to those conditions. They could feed on microorganisms and perhaps vegetation similar to that on Earth's ocean floors. Given that we have only a few images of the Venusian surface and they were taken in the 1980s, we could easily overlook an entire Venusian ecosystem that survived for hundreds of millions of years, no matter what. However, if life really originated with the solar system, a habitable world doesn't have to be similar to Earth, like Mars or Venus. There are far more celestial bodies in the solar system where a variety of exotic creatures might be living. Take at least Mercury. There seems to be no chance for life here. This planet is only slightly larger than our moon and much closer to the sun than Venus. But due to the lack of atmosphere, instead of the constant heat, there are terrible temperature swings from 430 degrees Celsius during the day to minus 180 at night. It's basically the difference between molten lead and liquid nitrogen. Even the most resistant bacteria are unlikely to withstand such extreme fluctuations. However, potential mercurial life doesn't necessarily have to be subjected to such a trial. Previously, scientists believed that Mercury's surface was peppered only with impact craters. However, a closer look at the images revealed gorges, gaps, and other complex terrain features absent, for example, on the moon. At first, planetary scientists assumed all this was the result of the most powerful asteroid impact in Mercury's distant past. The shockwaves from that asteroid strike have spread across the planet and caused all this destruction, just as the impact of a large stone on the windshield of a car covers its entire area with cracks. But quite recently, this widely accepted theory has been challenged by Dr. Alexis Rodriguez, a research scientist at the Planetary Science Institute in the U.S. Together with his colleagues, he studied many old photos of Mercury's surface taken by NASA's Messenger space probe and concluded that we're actually witnessing the effects of the Great Evaporation. Everything looks as if beneath the surface of ancient Mercury, there was a thick layer of water with dissolved organic substances. That is, in fact, an ideal environment for life to thrive. But then some catastrophic event instantly vaporized this organic soup. This may have happened when Venus pushed Mercury into its current close orbit around the sun. Immense layers of the fractured crust collapsed into the voids left by the water, forming a strange relief that we observe today. But if life managed to evolve in the ancient waters of Mercury, could it survive the Great Evaporation? In 2017, astronomers suddenly discovered a surprising amount of water ice trapped at Mercury's poles. So could we be mistaken in believing it all boiled away in the planet's interior? If Dr. Rodriguez is right, there are many secluded corners in the planet's bowels that are well protected from temperature extremes on the surface. Here on Earth, scientists are just beginning to explore deep voids like the mysterious Cheve Cave in Mexico. There's a whole lost world of organic crystals and weird growths where virtually alien microorganisms thrive in complete isolation from us. Who knows? Maybe they are the Mercurians' relatives. Right now, the caves of a small planet could hide an exotic ecosystem that's developing due to heat waves from the surface. But even if that's the case, we won't be able to uncover the mysteries of the Mercurian caves for a long time to come because no space agency is planning missions to this planet yet. Nevertheless, NASA is seriously aiming to look for life on another tiny world, much further from the sun. When the two Voyager probes entered Jupiter's orbit in the spring of 1979, these images wowed the mission operators. The smallest of the gas giant's four major moons, Europa, showed a frozen surface crisscrossed by many mysterious streaks. Very similar lines can be seen on the surface of active glaciers on Earth. That means there's water under the ice. But how did it make it to Europa, which receives only 4% of the solar heat available to our planet? Apparently, the moon is warmed by Jupiter's tidal effects. That is, the gas giant kind of needs Europa with its powerful gravity. Thus, according to geologists' calculations, Europa's 10 to 30 kilometer thick ice crust hides an ocean up to 100 kilometers deep. So paradoxically, Europa, which is smaller than our moon, contains twice as much water as our Earth. In considering that the first organisms on our planet appeared in the oceans, this hidden water world is currently considered the most suitable environment for extraterrestrial life in the entire solar system. There's just one problem. The rise of underwater ecosystems on Earth was made possible by the fact that a sufficient amount of atmospheric oxygen dissolved into its oceans. After all, even fish need something to breathe. Previously, scientists believed there was nowhere for oxygen to appear in Europa's oceans. But at the beginning of 2022, a computational geoscientist, Mark Hess, reported observing an unusual process on the moon's surface. It turns out that harsh radiation splits apart water molecules in the ice into hydrogen and oxygen. And as a result of complex chemical exchange through intermediate tanks, these gases can reach the greatest ocean depths. It's easy to imagine the whimsical blind whales of Europa swimming up to the crust to breathe, and then they dive back into the warm layers to get some sulfur plankton, which doesn't need oxygen. However, even Mark Hess's most optimistic estimates of the amount of life-saving gas in the local ocean indicates that the whales of Europa are unlikely to be larger than Earth's sprat. The largest organisms on Europa may well be giant tube worms, similar to those that surround deep-sea thermal vents in Earth's oceans. The task to assess whether it's actually realistic is entrusted to NASA's Europa Clipper mission, scheduled to be launched in Jupiter in 2024. Although if we want to imagine extraterrestrial organisms beyond Jupiter's orbit and even have a chance of discovering them, we'll have to abandon traditional notions about extraterrestrial life. The frozen fringes of the solar system could be home to the most bizarre aliens. On January 14, 2005, the tiny Huygens probe did something no terrestrial probe had done before. It descended into the atmosphere of a celestial body in the outer solar system. It was the amazing Saturn's moon Titan, which is larger than the planet Mercury. During the descent, Huygens cameras captured an absolutely breathtaking, unearthly landscape, a rocky plateau blanketed in a thick orange haze. But that's not a hot supercritical ocean of carbon dioxide as on Venus, but a dense nitrogen-methane veil cooled to minus 180 degrees Celsius. In such conditions, the normally gaseous methane becomes liquid and forms a complex network of rivers and lakes on Titan. All this strikingly resembles the life-filled water landscapes of Earth, except those waters will instantly turn any fish we know into ice, unless, of course, it uses a radically different chemistry. In 2015, a team of scientists from Cornell University, led by Paulette Clancy and James Stevenson, made a startling discovery. They managed to simulate the basis of alien life with alternative chemistry, the azotosome. On Earth, cells use phospholipid membranes to absorb life-giving water from the environment, and this model is based on nitrogen, which is abundant on Titan. Instead of water, the azotosome can allow liquid methane to pass through. In addition, the azotosome remains active even at ultra-low temperatures. If there's life on Titan, it indeed uses this chemical mechanism. But what would these organisms look like? The Huygens space probe discovered that due to thick clouds, the sun's rays barely reach Titan's surface, meaning that local life can hardly use an analog of photosynthesis for energy generation. However, the atmosphere here is still heated enough to create a climatic cycle so that liquid methane evaporates from the surface, forms clouds, and then falls back as rain. And according to astrobiologists, life may well exist on this border of energy exchange. These are probably giant azotosome membranes that slowly slither across Titan's surface in search of the warmest places, just like terrestrial lizards. But the structure of these organisms is closer to giant amoebas or mysterious slime molds. Given that the Huygens photos from Titan's surface are somewhat blurry, such an extraterrestrial creature may lurk in one of the images we have, and we just didn't notice it. But the weirdest extraterrestrial creatures won't waste their time on small moons like Titan. The most common habitat in the solar system is not the surface of planets or subsurface oceans. Those are millions of cubic kilometers of giant planets' gas clouds. But if space probes made it possible to study the atmospheres of Jupiter and Saturn from Earth to provide credible assurances of the absence of signs of extraterrestrial life, we can't say the same about the most distant ice giants. I'm talking about Uranus and Neptune. These planets were visited by Voyager 2 only once in the late 80s. Its camera unexpectedly captured the Great Dark Spot on Neptune, a gigantic atmospheric storm similar to the Great Red Spot on Jupiter. Yet, the Neptunian winds turned out to be much more furious. They rush at speeds of up to 2,100 kilometers per hour. That's an absolute record for the solar system. Scientists attribute this active climate to Neptune retaining much of its heat since its formation. If extraterrestrial life originated on it at the same time, it's hard to imagine a more luxurious environment in this cold region. But since gas giants have no solid surfaces, they can be home to highly exotic creatures, perpetually floating in the dense layers of the hydrogen-helium atmosphere. They feed on wind energy and low-temperature chemical reactions, and they reproduce with the help of liquid ammonia, toxic to terrestrial life forms. In 2021, French planetary scientist Tristan Guyot tried to explain why, unlike Jupiter and Saturn, no traces of ammonia were found in the clouds of Uranus and Neptune. The scientist suggests that ammonia simply freezes deep under the outer clouds and settles down in the form of slushy hailstones, the so-called mush balls. On their way, they accumulate particles of water ice, potentially reaching up to 1 meter across. As the mush balls fall deeper into the atmosphere, they encounter even warmer temperatures, where they eventually evaporate and force the ammonia up. Is it just me, or do these mush balls look like the eggs of giant floating creatures, or at least a great place to lay eggs? The process of their descent through the different levels of the atmosphere can take days or even weeks, which is enough for the ripening of embryos in heated ammonia tanks. And it may be just a small part of a complex extraterrestrial ecosystem in the clouds of ice giants, waiting for us to discover it. Unfortunately, the next NASA mission will have a chance to peek into Neptune's clouds no earlier than 2049. However, the solar system has one theoretically life-friendly environment that we'll never reach. That's the interior of the sun itself, where temperatures reach millions of degrees. But what could live there? In a scientific paper published in 2020, Louis Ankardoki and Eugene Chudnovsky from the City University of New York claimed that complex non-atomic structures of cosmic strings and magnetic monopoles could form in hot stellar plasma. Both are hypothetical objects, but if they're real, plasma bacteria may be exchanging energy and reproducing inside the sun right now. Which forms of extraterrestrial life seem most plausible to you? If creatures from other worlds of the solar system are still only hypothetical, these incredible rotating planet models from MOVA globes are absolutely real. No electricity, no batteries, no sloppy cords. Literally, the Earth itself keeps them in motion. This artificial technology uses hidden magnets powered directly by our planet's magnetic field. The collection has over 40 designs with graphics for the planets and satellites provided by NASA itself. Use my promo code RIDDLE10 when ordering on movaglobes.com and get a 10% discount. All the information is in the video description.